Mountains of metal scrap are sorted across a wide industrial yard. Cranes haul massive blocks of copper and zinc toward the melting furnace. Heat bends the air as the metal turns liquid, glowing white-hot. This is where the long journey begins, the journey that will one day become a 7.62 round. The molten alloy is tested for purity and balance. Then it flows into continuous molds that shape long brass billets. After a controlled cool-down, the billets are rolled into bright brass coils, the first real step toward the casing that will hold an explosion. The coils move to precision cutting. Perfect circles are punched out. The blanks. Every disc must match in thickness, no exceptions. Laser scanners hunt for microscopic cracks, ejecting anything that falls short. One flaw now means failure later. The blanks enter deep drawing. Pressure stretches each disc into a narrow cup. Brass that's too hard cracks. Too soft, it warps. Lubrication, temperature and force have to land in perfect harmony. This is where the metal is tested, and where mistakes hurt the most. After the brutal stretching, the cups hit the annealing stage. High heat restores the flexibility the metal lost moments earlier. A controlled cool shapes the microstructure that must survive the powder blast. If this step fails, everything fails. Now the cases reach their true size and thickness. Dimensional accuracy is everything. 1/1000th of an inch off can change ballistic performance. Sensors and operators watch every detail, making sure the metal behaves the way science demands. Lead and copper alloys are melted and extruded into heavy wire. The wire is chopped into identical cylinders, the raw cores that will become bullets. At this point, they hold no shape, only potential. Progressive presses sculpt the nose, body and base of every projectile. The aerodynamic profile isn't style, it's survival, stability in flight, reliability in a 7.62 chamber. The shape determines everything that comes next. The bullets receive surface treatment and polishing. The finish reduces barrel friction and brings uniformity across the entire batch. Smooth surfaces, consistent weight, identical drag, all essential for accuracy. Powder begins as nitrocellulose mixed with stabilizers, turned into uniform grains. Primers receive sensitive compounds and pass strict electronic checks. A cartridge is only as good as its chemistry, and chemistry doesn't forgive errors. Cases are primed, filled, and topped with polished bullets. The line seals each round with scientific precision. Watching the process up close reveals a level of engineering most people never see. Stay with us. The final stages show how everything comes together. Crimping locks the bullet in place. The final sizing die brings the cartridge to NATO dimensions, ensuring smooth feeding in any rifle built for 7.62. This is where consistency stops being optional. High-speed cameras and precision scales check every round. Structure, weight, alignment. No guesswork, no shortcuts. Anything out of spec is kicked out immediately. Only the best survive this gate. Inside reinforced firing chambers, fixed rifles test sample rounds from each batch. Sensors record peak pressure and muzzle velocity. Every lot must meet strict ballistic standards. If it fails, the whole batch is rejected. No second chances. With testing complete, the approved rounds return for final polishing, marking, and sorting. Every step links to the one before it, a chain of precision that only works when everything is aligned. The line reaches full momentum. Cartridges are grouped, inspected, and packed into transport trays. This is the peak, where thousands of tiny decisions made across the factory finally converge into a finished round.
Leave behind what
Pallets stack high, ready for shipment. The noise fades as the factory winds down, and on a quiet workbench, one single cartridge remains, the final echo of a process that began with raw metal pulled from the earth.